What about carbon dating? This is semi-technical. I'll try to keep it as simple as I can. But something to keep in mind, a lot of people say carbon dating proves the Earth is millions of years old. Well, something you got to keep in mind is carbon dating is only used to date thousands of years. They always get that mixed up. It's radiometric dating, like potassium argon dating, that dates rocks for millions of years and billions and stuff like that. So the Earth's atmosphere contains 78% nitrogen, 21% oxygen, which is probably more like 35% oxygen before the pre-flood, according to the amber and stuff we dug up, and 6% carbon dioxide. And in that 0.06% carbon dioxide, there is 0.0000765% radioactive carbon-14. So it's kind of combined together. So how is this carbon-14 produced? This is how they date things, but I'll just point it out. So the cosmic rays shine down on the Earth's atmosphere, which is mostly nitrogen, 78%. It collides with it, forms an unstable isotope, which forms carbon-14. Carbon-14 then combines with the carbon dioxide, and it lands on the plants, and the plants take it in, and the animals eat the plants, and the humans eat the plants and the animals. So you get this whole cycle. So it's assumed that everybody has the same amount that's in the atmosphere, that's in the same people, the 0.0000765%. So once a plant or animal dies, they can start the clock, because the organism dies. It's not eating anything because it's dead. So it's going to continually decay from that point on. Continually decays. I like the flowers. Okay, what is half-life? Well, it's basically the amount of time it takes for the carbon-14 or whatever unstable atom you want to think of. But anyways, half the time it takes to decay back to its original state. And the half-life for C14 is 5,730 years. So here's an illustration to help you out. So at time 0, when the organism dies, supposedly it has 100% carbon-14 in it, which would be the amount that's in the atmosphere. Well, whenever a half-life occurs, 5,730 years, one half-life occur, half of it would turn back to nitrogen-14, and then 2 half-lives, 3/4 of it back to nitrogen-14, a better way to explain it. So if C14 is constantly decaying, will we run out of C14 in the atmosphere? Something I'm about to cover in a minute. So we got some different assumptions here. So has the half-life always been the same? This is not something we can test or observe because we haven't been here with the technology we have today to test to see if the decay has always been 5,730 years. And the starting amount of C14 in the atmosphere, has it always been the same? Which I'll point out it hasn't. And the starting amount of C14 in the fossil, how do we know how much that fossil had when it died? We don't know. We can't measure that. And these are critical details. Okay, so I'll reiterate on it. You have the cosmic rays, the sun, shining down the atmosphere, nitrogen-14. It collides with it, forms carbon-14. Carbon-14 combines with oxygen to form carbon dioxide, lands on the plants. The animals eat the plants, the humans eat the plants and animals. Everybody has it in them. All right, so this is the equilibrium assumption that I'm about to cover. Is the carbon-14 being added to the atmosphere, is it the same as it's being removed? Now, if it's at equilibrium, it should be the same. So the amount that's being added should be the same as leaving the atmosphere by decay. That just shows you a little better. So it would be constant at this level. It's like shooting a barrel full of holes, and it has water, and you're pouring water into it, and the water's leaking out. There's going to come a point, if you're pouring at a consistent rate, that the water coming out will be the same as you're pouring in, and it'll just stay at that rate. So let's do some empirical science here. You walk into a room, you see a candle lit. Okay, how are you going to know when it was lit? Well, we can look at it, we can measure it with a ruler here, and we can figure out, okay, it's 7 inches tall. Then we can stare at it for a couple hours and see that, oh, it's burning at a rate of 1 inch per hour. So when was it lit? Can anybody figure it out? That's the thing, you can't figure it out. Here's some assumptions you have to keep in mind. How tall was it when it started? We don't know. This is the same thing with the carbon-14. We don't know. And then has it always burned at the same rate? We don't know. It could have burned faster when it first started. We don't know, or slower. So we don't know. Now the magnetic field, which Dan pointed out, is drastically declining, 10% in the last 150 years, and it's estimated that it's been 40% in the last 1,000 years. This is a big deal because Earth cannot sustain life if the magnetic field is too strong. So this actually limits the age of the Earth to at least 25,000 years by some estimates. Some are even higher and some are lower, but they're around that age. And then something else to point out is that carbon dating would have been all messed up because the magnetic field deflects these cosmic rays, and they couldn't get into the atmosphere to create carbon-14, so there wouldn't have been as much. And then you have the canopy of ice. That would screw it up too, because you just don't have all these rays penetrating the atmosphere. There probably wasn't hardly any carbon-14 at all before the flood. And that's also going to mess up your dates. This guy admits that radiocarbon-14 is forming 28 to 37% faster than it's decaying. That's a big problem. So you have a rubber ruler here. It's like you're getting more and more in the atmosphere. So what we're measuring today, let's say today is 0.000765%. Well, we're measuring something that we think is 2,000 years old by our measurements today, but we don't know how much was in the atmosphere then. We just know it was less. So we have this rubber ruler. It's not going to work. Now, fossils are dated by the position in the geological column, which does not exist. And don't let people tell you that they're dating it by radioactive dating and stuff, because they're not. I mean, just recently they're starting to do this. And keep in mind, it would not have been feasible unless the geological column was there first. This is how they calibrated it. It was based off the geological column, which they made up. So we'll cover a couple examples. This is always fun. We can cover this all day, but I only put 6 on here. So, let's see, the year 1949, a little bit after Dr. Libby invented this method, the lower leg of a mammoth was dated to be 15,000 years old, while the skin of that leg was dated to be 21,000 years old. Seems like we got a little problem here. It's the same animal. Okay, this is in 1963. Living mollusk shells were carbon dated to be 2,300 years old. I wonder what I would carbon date at. I wonder how old I would come up to be. That'd be kind of interesting. A freshly killed seal was carbon dated to be 1,300 years old. That was in 1971. It doesn't seem that they're getting much better with time here. And in 1984, shells from a living snail were carbon dated to be 27,000 years old. I got these articles on my computer. They're pretty funny. But it's not working, folks. Things that are alive are not 27,000 years old. Now I'm going to briefly cover a couple of the rock dating methods. I can't get into how it works because we can sit here. This is a whole seminar within itself, just the whole dating methods and what does it work. So 1959, this mountain in Hawaii erupted, and we know when it erupted. The rock was formed in 1959, but the rock dated to be 8.5 million years old, plus or minus 6.8 million years. That's a pretty big range there. You got like a huge amount of percentage of error. Mount Etna basalt, Sicily, erupted May 1964, and it dated to be 700,000 years old, plus or minus 100,000 years. 10,000 years, sorry. But that doesn't make much sense. We know the rock was formed in 1964. Now it's dating at 700,000 years old. Mount Laysan, Plagioclase, California, erupted 1959, dated to be about 100,000 years old. 1915, I think they're a little far off there. Okay, so what about cavemen? This is the fun part. I enjoy this part. Is it possible for an ape to become a man? Somebody saw that picture earlier. So here's the world's most wanted caveman. And here's a former caveman. Okay, this is Nebraska Man and his wife, shown in London Illustrated, 1922. Now, keep in mind, they scientifically built this guy from one tooth. I don't know how they got this guy with his wife from one tooth, but they did it. That's some good science there, I can tell you that. And because they saw a tooth that looked kind of like ape and then kind of like human, and they decided that, okay, this is what we're going to draw. So this is what they drew. Now, Nebraska Man was used as fossil evidence in the Scopes monkey trial, which, by the way, the creationists won. It was against the law at one point in time in Tennessee to teach evolution. It's not anymore, but it used to be. So this is the claim is that it's a 1 million year old intermediate link between apes and humans. Well, the truth is the real Nebraska Man's a pig's tooth. It was later discovered as a pig's tooth. That's not really much science there. This is Piltdown Man. This is what they found. The parts you see up there and that are darker, this is what they found for Piltdown Man. Segment of a lower jaw and a segment of human skull. So you got ape jaw, human skull. So this is found in Piltdown, England. Hence the name, 1908, 1912. The claim is it's a 500,000-year-old intermediate link. And they're basing this off the geological column. This is how they're basing it right here. But so in the 1912 ad in New York Times read, "Darwin's theory proves true." And it was featured in textbooks and encyclopedias all over the world. But in 1953, scientists studied the bones and found out the truth is it's a fraud, 600-year-old bones. And with the technology we have in modern day, we can prove this. And 1956, a ad ran in the Reader's Digest, Great Piltdown Hoax. For more than 40 years, this was taught as science. And it was used all over the world. But he stained the bones he found and filed them down with stuff, and they could prove it. Not science. So here's Ramapithecus. In 1930, this is what they found, this lower jaw. What they drew was whatever that is, I'm not sure. But that's what they drew from this jaw. I don't know how they got the rest of his body. But the claim is it's a 14 million year old link between apes and humans. Well, the truth is that in 1970, a baboon living in Ethiopia was discovered, and it had the same dental structure and similar morphological features found in the Ramapithecus. And Ramapithecus was later dropped from the human line. It's no longer considered part of the evolutionary line.